Welcome back, Union High School Pre-Calc. I hope you had a good first week of distance learning. We are going to continue on here with limits this week. What I'd like for you to do is try this warm-up. We're going to be doing limits the last way, analytically, today, and we need to kind of refresh some factoring skills. So pause the video, try these, and then let's come back to it. All right, here are the answers we got, so you can check your work, see if you agree. And then before we move on, I do want to kind of do a review of limits graphically. So I'd like for you to try finding these three limits and these three function values. Again, pause the screen and then click play when you're ready. All right, so here's what I've got for our answers. Check yours, see if they match. Remember that a limit is what y we're approaching, and then the function value is what y is at that particular x, okay? And the two may or may not be the same, alrighty? So that they are not dependent on one another. Okay, well, let's start limits algebraically, also known as limits analytically. This is kind of a two-step process. The first step is to plug in the value of c, and that is the number x is approaching, into the expression. Okay, so from there you have four scenarios. Let's write those four scenarios down together. The first scenario is that you plug in this number and you just get some nice number out for your expression, and then yay, you're done. That's your answer. Okay. The second scenario is maybe you get 0 over some number that's not 0. Right, so like 0 over 5. Well, that's actually just a subset of scenario number 1, right? This is equal to 0, so my answer is 0. Yay, done. Okay, third scenario is going to be the reciprocal of that. Let's say you get some number that's not 0 over 0. Well, in this case, if I have 5 over 0, that's undefined, right? So my limit is d and e. I'm just going to write d and e. Yay, I'm done, okay? The fourth scenario, what do we have left? The scenario we have left is 0 over 0, and this is what we call indeterminate form in mathematics, okay? So it's not yet determined. Is it 0? Is it undefined? Is it 1 because it's something over itself, or is it something totally different? In this case, we have to do more work to figure that out, okay? And we're gonna learn techniques in calculus that will work for any indeterminate form, but we are going to be able to use some factoring today, some algebra, to be able to do some more work as well for certain kinds of indeterminate forms for limits. Alrighty, so let's try some of these together. Would you write this in your notes, please? The limit as x approaches 3 of x squared plus 1 all over x. And remember, step 1 is we're just going to plug this number in for any x that we see into that expression, okay? And I can do just a mental check. Am I going to get 0 over 0? I can tell I'm definitely not, right? So we are going to just plug 3 in for all my x's. That gives me 3 squared plus 1, or 10 in the numerator, and 3 in the denominator, and that's my answer. Alrighty. Would you write the second one in your notes, please? We've got the limit as x approaches pi over 2 of e to the x times sine of x. So again, I'm going to plug pi over 2 in for each x I see into that expression. Again, I can see I'm not going to get 0 over 0, so let's start plugging in here. I'm going to get e to the pi over 2, which is irrational. That's fine. I'm going to leave it like that, times sine of pi over 2, right? Pi over 2, or 90 degrees, is right here on the unit circle. That's the ordered pair 0, 1. Sine is the y-coordinate, so sine of pi over 2 is what? It is 1, so I have e to the pi over 2 times 1, which is just e to the pi over 2. You knew we were going to come back to that unit circle at some point, right? Okay, let's try this one. Can you write this one in your notes, please? We've got the limit as x approaches 3 of x over x minus 3. So again, I'm going to plug 3 into any x I see into that expression. But what happens here? we get 0 in the denominator, but not in the numerator, right? I get 3 over 0. That is undefined, so that must mean that the limit does not exist. 3 over 0. Alrighty? Okay, so that's just good old direct substitution, yeah? Let's try some where we have to do more work. Can you write this limit in your notes, please? We've got the limit as x approaches 4 of x squared minus 16 all over the quantity x minus 4. And now I can see if I plug 4 in for x, I am going to get 0 over 0. Right? And I do have to denote that on the next year on the AP Calc exam, okay? So I know right now you're just kind of plugging these in and not needing to show a ton of work in my math lab, but just kind of get in that habit of either you can just put it in parentheses, you can do a little arrow. What you cannot do, you cannot say that this is equal to 0 over 0, okay? You will lose points on the AP exam next year if you do that. So just a little arrow will be fine, or parentheses, but you do have to show that you tested to make sure this is in indeterminate form, okay? All right, so do more work. Well, our do more is, maybe you could guess it from our warm-up, is going to be to factor, okay? So yes, I do have to rewrite this limit as x approaches 4 each time. Factoring here, difference of perfect squares. The nice thing about factoring rationals in calculus is something's gonna cancel, okay? So I'm pretty confident one of my factors in the numerator needed to be x minus 4 since I had that factor in the denominator, okay? So here we get this nice cancellation. Any ideas what we do now? Let me rewrite what I have left. So now I've just got x plus 4 left, right? So now I'm back to where we were. Now try the limit again, okay? So now plug 4 in for all your x's into that expression. And what do we have now? Yeah, we have 4 plus 4, or 8. And that is our answer, okay? Let's take a look at the graph so you can kind of see this graphically as well. You can see if I draw my guide here as x approaches 4 from both the left and the right, my y values are going to approach 8, right? So if I approach here, boop, 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 8, and if I approach from this side, 8 as well, right? However, what is the function value? What is f of 4? So you can see from the picture here, f of 4 does not exist, right? And we could have seen that analytically as well, because as soon as I remember function values, what is y right at 4, not around 4, okay? Or when I plugged in 4, I got 0 in the denominator, so my function value does not exist, but the limit did, okay? So what is going on around x equals 4 is able to be calculated. All right, let's try another one like that. Can you write this one in your notes, please? The limit as x approaches 0 of x squared plus 3x all over 5x plus x cubed. All right, and we can see that we are going to have a problem here, right? If I plug 0 in for all my x's, I see that this is an indeterminate form. Remember, please do not say this, okay? We don't know what the limit is yet, so we can't say that the limit is equal to 0 over 0. We can say, we can do a little arrow there, okay? All right, so what do we think our do more is here? What kind of factoring could we do? Yeah, let's try factoring the greatest common factor, which in both the numerator and denominator is x. So if I take out an x in the numerator, I'm left with x plus 3 as the second factor. And if I take out an x in the denominator, I've got my second factor to be 5 plus x squared, right? Okay, so now we can do some canceling. So I'm going to rewrite this just so it's clear what we're plugging 0 into. All right, so now I'm going to plug in 0 for any x I see in that expression. So that's going to give me 0 plus 3 in the numerator. and 5 plus 0 in the denominator. So final answer, my limit as x approaches 0 is 3/5. Okay, not too bad. All right, let's try some piecewise. I'm going to start off doing one where I give you the graph and the equation of the function, and then we'll try just the equation. So let's start by looking at the graph. So I'm going to draw my guide here. Okay, and we want to approach x equals 1 from the left and the right, and then find the full limit as well as f of 1. So if I approach coming from the left, it looks like my left-hand limit is it going to exist, first of all? It is going to exist, because remember, it's what we're approaching, not necessarily what we land on. So we're approaching y equals 1 from the left. And then it looks like we're approaching 2 coming from the right, which means the full limit is what? It doesn't exist because the left and the right are different. So let's write that. Let's write what we have so far. We found that the limit as x approaches 1 from the left of f of x is 1. The limit as x approaches 1 from the right of f of x was 2, which means that the full limit is what? It can't exist, right? Because the left and the right are different, okay? And then what about f of 1? F of 1 in this case is where the closed circle is, right? So f of 1 is going to be 2. Okay, so now let's pretend that you are not given the graph, and let's see, could we figure out the same thing using just the equation here? Okay, so let's see. If I want to find the left-hand limit, I would be looking at all x's less than 1, right? So I'd be looking here. So because of that restriction there, x is less than 1, that tells me I can use this expression to find the left-hand limit. Okay. Similarly, if I want to find the right-hand limit, I'm using x is very close to 1 but greater than 1, right? So that inequality right there tells me I can find the right-hand limit. Remember, the equal sign has nothing to do with it. That's the function value, correct? And that's different from the limit. So x is greater than 1, not necessarily equal to 1, would give me my right-hand limit. X is less than 1, in this case, would yield the left-hand limit. So let's try this and see if we get the same thing we did when we found this graphically. All right. Okay, so if I plug in 1 for x into this expression, it should give me my left limit, right? So when I plug in 1 for x, I just get 1, right? And that checks out. Okay, now let's go to the bottom expression, which was going to give me my right-hand limit. Let's look at this expression. If you plug in 1 for x into that expression, you get negative 1 plus 3, which is indeed 2, right? And now that you've got your left and your right hand, and they're different, then it checks out that your full limit would not exist, correct? All right, and then how would I find the function value from this expression, from that equation there? Well, just like that's an algebra 2 question, right? Look at where x is equal to 1 right there. And if I plug again 1 into that green box, I get 2. Okay? All right. All right, let's try one where I do not give you the graph. Okay, so it says find all limits of f of x as x approaches 0, then find f of 0. Okay, so let's start with the limit as x approaches 0 from the left-hand side. If I'm coming from the left, I would be using x is less than 0. So again, this is going to give me my left. So I'm going to look at this expression here, and I'm going to plug 0 in for any x's. Notice there are no x's, so I always will get an output of negative 1 no matter what the x is there, as long as it's less than 0. Okay, how about the limit as x approaches 0 from the right-hand side. Well, if I'm coming from the right, I would want to be looking where x is greater than 0. Okay, so I'm going to come over here and look at that expression, plug in 0 for x. Again, notice there are no x's, I just get 1. So now I've got my left and right, which allows me to find the full limit. What is the full limit in this case? Yeah, it does not exist. How come? Again, because left and right are different, okay? What do we think about f of 0 here? So in this case, f of 0 does not exist either. Notice there's no place in my inequalities where x is equal to 0, okay? So f of 0 does not exist in this case. All right, here's what I'd like to do next. Can we get kind of a graphical picture of this and maybe go sort of backwards and see if our answers line up here? So let's go here. So my graph is y equals -1 for all x's less than 0. So that would be all my negative x values, right? So when x is negative, y is this constant -1, okay? And when x's are greater than 0, in other words, when they're positive, my output is +1. Okay, so it looks kind of like this, like broken railroad tracks, right? And no closed circle at 0, right? I don't have a function value there. This is actually a really common function in calculus, so I'm wondering if we can sort of avoid that piecewise notation and just get this into one nice f of x. Okay, let's think about it here. Let's first think about that green segment, all right, the positive x values. So no matter what my input is, my output's always 1. So one way to get 1 is just x over x, right? Anything over itself is 1. So this would check out for positive values. However, as soon as I try this for negative values, like if I try -5 for x, now I'm getting a +1 out instead, and I would really like to get a -1. So any ideas? What do we think about throwing absolute values around just one of the x's? And it doesn't matter, I chose the numerator, but you could have done the denominator as well. Let's see, does it check out now? Well, let's try it. Let's try our let's try our negatives first. So plug in a negative x for me, like try this for -10. I would get +10 over -10, which is indeed -1, right? And that would be true for any negative input, okay? Let's try this for a positive x value. Try it for like +100. So I'd get 100 over 100, which is 1, right? And that would be true for all x's greater than 0, and that is exactly what we wanted, right? And this is again true for any x other than 0. Okay, so this is a really important function. I'd like for you to write this in your notes as our kind of final definition. The sine or signum function, signum is sine in Latin, is given as the absolute value of x over x for all x's different than 0. All right, so that's a really important function in calculus. It's just, it's just that broken railroad track function, right? That's all the graph looks like, but we actually end up using it quite a bit in AP Calc. Okay, so I'm going to ask you kind of some algebra questions with this now. How do we shift a function left or right? Yeah, we add or subtract a real number on the inside of the function, right? And what do we mean by the inside of the function in this case? Well, it would be anywhere you see an x, so you would need an in, like a plus c by that x as well as by that x, okay? For example, see if I can get, woohoo. Let's try this here. Okay, what would f of x equals absolute value of x minus 3 all over x minus 3, valid for all x's not equal to 3, look like? So do you see how that's a shift because we've subtracted 3 on the inside of the function? Again, x's appeared twice, so that minus 3 would need to appear twice, and it does. So this takes that parent function and shifts which way? Shifts right 3, okay? Notice it does not stretch it. It does not shift it up or down. So it would look like this. If I've gone to the right 3, that jump is now at 3 instead of at 0, but I've only shifted it, okay? These values here, these y values are still -1 and +1. Okay, I've just took those broken railroad tracks, that blue and green graph, and shifted it to the right 3. So it does not affect the y values, right? Those are still -1 and 1, okay? All right, so let's try this as our final example here. Find all limits of f of x as x approaches -5, then find f of -5. All right, so I see that that's my sine function. So my outputs are -1 and 1. Again, it's just giving you the sign. The y value is just the sign. -1 for a negative output, +1 for positive. So let's get a graph going here. This takes that sine function and shifts it to the what? Left 5. 1, 2, 3, 4, 5. +1. -1, all right? Okay, so now it said find all limits, so I'm going to draw my guide right there, yeah? Okay, so if I take the limit as x approaches 5 from the left of f of x, so I'm approaching from the left there, no, it's not right. I am approaching what y value? I'm approaching -1, right? And if we want to find the limit as x approaches 5 from the right, then I'm approaching +1, meaning that the full limit, the limit as x approaches 5 of f of x does not exist, right? And what about f of -5? Well, we could have seen right here we don't have any function values when x is -5, so f of -5 also does not exist, okay? All right, so that was limits analytically. You've got my MATLAB homework packet on homework on this due Sunday at 9 p.m. And then we'll have sort of one more lesson on limits. That's limits involving infinity. And then you'll have a homework on that. And then we'll kind of have a wrap up of all limits, Desmos activity on Friday. Okay? All right. Thank you all so much. Hope you're doing well. Again, if you get stuck on anything, please reach out to your teacher. And we will see you back here next time. Bye.